Hello everyone and welcome back to another Universe Sandbox 2 video, and today we've got quite an interesting idea which sparked my attention when I actually saw it, because if you've seen on my channel before, I think I did it, where we made all the planets Jupiter size, and I think loads of other people have done it as well. But what if we make all of the planets Mercury sized? So yeah, that's when we did, I think it was when we, I can't remember if I did it or not. I definitely made all of the planets 100 masses of Sun, and that was insane. But I don't think, I can't remember if I've made them all the same size as Jupiter before. I've definitely seen other videos on it. I haven't watched them, but yeah, I think I've seen other videos about making all the planets Jupiter size, but I've never seen anything with making it Mercury size. So yeah, we're going to get into this because, yeah, whoever comments this, many thanks for the idea. And also, if anyone else has got any ideas, feel free to comment them down below and I add them to my list of things to do. And yeah, let's get into this. And also subscribe if you haven't already, because yeah, become one of us. Become one of the math bros, I guess. That I don't know. Yeah, help us on the journey to 1,300 subscribers, because that'd be cool. But anyways, it's gonna be interesting to see how Earth turns out with as a smaller planet, but with the same atmosphere. So yeah, that could be a little interesting. So anyways, Mercury. Let's go to the main star of the show today. So Mercury, 4.49 masses of Moon. It's got a radius of 2,440 kilometers in size, so that's about 4,880 in diameter, I believe. Density of 5.43. I don't even know what that is. G/centimeters cubed. I don't. Oh, gram. I think that's grams/centimeters cubed. So yeah, that's a pretty high number, but I'm not really very smart with density there. What else? Got age 4.5. Galactic years or billion years, like everything else here. Surface temperature is around 215, but it ranges. And it's the closest planet to the Sun. It takes 58 days to 58 Earth days to spin around once, which means I believe its year is longer than its day. So I think this takes about 55. Oh no, it takes 87 years to go around the Sun, and you see it. Yeah, 2 days on Mercury is longer than 1 year on Mercury. So that's pretty crazy. Anyways, let's get into this. So let's go to Venus now. So 2,440. Let's do it. So 2440, like that. Oh, and look at Venus. It's so small and cute. Anyways, Earth. Let's go. Also do the same. So 2440, like that. Mars as well. Let's do it as well. 2440. Oh, whoops. 2440, like that. So Mars is a lot smaller. Jupiter. Oh, this is going to be interesting. 44. Wait, no, it was 240. No, 2440. Damn it. I'm so bad at remembering the numbers. There we go. Alright, Saturn. Let's do the same with you. 2440. So it's making these guys literally a fraction of their original sizes, which is pretty crazy. Let's go to Uranus next. The custom Uranus, I might add. Oh, that light blue just looks so much better than the regular Uranus you get in the normal simulations. That light blue, I'm so proud of that. That is just that is just awesome. Anyways, 2440. I think I'm like the only Sandbox YouTuber who's got like all these cool custom objects. I've never seen any other. I don't really watch many people play Universe Sandbox, but from what I've seen before I started making videos, I've never seen anyone with custom objects, so, or like a custom solar system or anything. So yeah, if any of you guys have got your own custom simulations with like custom planets like Uranus here, which is no longer even a gas giant, which kind of sucks. I guess it just didn't have enough hydrogen on it to make it into. Yeah, it doesn't. Look at that. So because it's so small, the amount of hydrogen on it isn't enough to make it into a gas giant. So now it's rocky with a lot of frozen water on it. That's pretty crazy. Alright, Neptune, my favourite planet. Let's check you out. So I've already done that. What am I saying? Next up, Pluto, because I generally believe Pluto should be classed as a planet. So yeah, we're definitely making that into the correct size. But Pluto is actually getting made larger here. So now Pluto can really be classed as a planet since it is large enough. We'll do the same with Eris as well, because yeah, I believe that should be as well. And Planet 9, this probably won't have a big effect, but we will do it out here as well. So let's go like that and add it in. Oh, Planet 9 has the same problem as Uranus there. Anyways, so now they're all the size of Mercury here. Let's actually go and compare them. So which one has the most mass, for instance? So, oh, look at this. They're so small and cute. Look at this. Oh, even Pluto. Look at that. So we've got Earth. So let's go by mass. So obviously the Sun is just going to be the Titan here. But okay, so Neptune has still got 17 masses of Earth. So I don't even know what's doing that. If we do that. Okay, apparently Neptune can have a mass of 17 Earths, but it can be this large. Or that's pretty weird. What is that? Okay, that's pretty weird, but okay, Neptune apparently has 17 masses of Earth here, which is pretty interesting. So that hasn't been affected, I don't think. How much is... Yeah, I don't think it has been affected. Neptune is... Let's have a look here. Is it... Say? But come on, let me... Why is it not highlighting it? It usually highlights. Oh yeah, 17.1 masses of Earth. So yeah, Neptune hasn't changed. Okay, next up we've got Earth at 4.56 moons in mass. And obviously all the same size. Then we've got the original Mercury, which is 4.49 moons of mass. Then we've got good old Venus here. So let's have a look there. So still very warm. 4.32 moons. Next up we've got Mars at 3.53. Then we've got Eris and Pluto at 3.43 and 3.42. So they are very similar. But I believe Eris has more mass normally anyway. It's just Pluto's slightly larger in the radius. So Eris is the most massive dwarf planet, but Pluto is the most largest dwarf planet, I believe. Then we've got Planet 9 at 1.13 moons. Poor old Jupiter at 1.1 moons. And we've got Uranus at 1.05. And Saturn, as the smallest, or the lowest in mass, is only at 0.559 moons. Then we've got all of the other planets here, or dwarf planets. Yeah, these guys are too small to be classed as planets, if you ask me. But yeah, Pluto and Eris, I think they are large enough to be classed as planets. So here are our set of planets. So that would give us 11 planets. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 planets, including Planet 9. So looking good. Anyways, I actually want to check out Earth and Venus. I think they're going to have the biggest effect here because their temperatures. I reckon because they have because they're a lot smaller in size now, they still have the same atmosphere or atmosphere size and surface pressure. So yeah, I want to see what happens here. Actually, no, Earth looks like it has changed. 2.53 ATM. I think it was only 1 earlier. So yeah, these have slightly changed. So let's hit play now. Let's see if anything happens to the temperature of Earth. So, well, it's freezing up apparently. So we'll keep an eye on that. Actually, let's just put it to 0 degrees just to check. Okay, so very interesting that. Wait, does it have an? Wait, it does have an atmosphere. Wait, what? Its atmosphere's gone. Has no atmosphere. Okay, that's interesting. We'll have to come back to that. Venus? Have you got? Okay, Venus still has an atmosphere. Oh yeah, Venus is really going here. Look at this. So it's got an atmosphere of 225 ATM. That's definitely more than normal. Venus is usually about 60 or 70 ATM, I think. Wait, let's get a Venus just to quickly check it out. So Venus normally is at 91.3 ATM. So making it smaller has increased the amount of pressure, or yeah, surface pressure here. So, and there's a massive greenhouse effect. Look at that. And then it reflects 99% of the light it receives. So that's changed. Oh no, that's infrared emission. See, what am I saying? It still reflects 88%. So it's very, very hot here. The structure on it's pretty much the same. So the temperature's just got hotter. But why has Earth lost its atmosphere completely? Is it because maybe it was because realistic climate mode is on? That's pretty peculiar. That could try it again with Earth. I guess we could add a second one in just to see if we can fix it. So let's add it in its normal spot here. So 1 AU. Let's now delete that Earth. Let's try and play around with this Earth here. So let's go 2440 like that. Now its atmosphere is still there. Let's turn off climate mode. Maybe that fixes it. So hit play. Okay, so now it looks like it's fixed it. So its surface pressure has gone up to 2.21 ATM regular rather than 1 ATM or whatever it normally is. So, wait, what is it normally? I think it's just 1 ATM, isn't it? It's 0.96. So it's pretty much 1 ATM. Yeah. So yeah, so the surface pressure has increased by making the object smaller, so that could be interesting. So we'll keep an eye out on Earth. I want to see how its temperature, if it changes or anything. Or maybe because the object is smaller, maybe it needs that extra surface pressure. But Venus, because we've made it smaller, its surface pressure's made it hotter than it normally would be. So I'm guessing Earth may heat up a little hotter than normal just by going how Venus went. That'd be pretty interesting. Anyways, Mars is still pretty much at its regular temperature here of minus 50 degrees. And then Jupiter, we can check up on you as well. You probably won't be able to hold your moons anymore, to be honest. Like, we could add the moons to Jupiter in, but we won't because we don't want to make this simulation go really, really slow. So yeah, I reckon if we added the moons to Jupiter, I believe Ganymede has more mass than this. So if we added Ganymede in, which is also larger than this as well. Yeah, I think it's slightly larger, yeah. So if we added Ganymede in, which has a massive 2.02 moons, Jupiter may become a moon of Ganymede, or do like a little binary thing with it, or they will just completely reject each other and fly out in different directions, because it has got less mass, so it may orbit Ganymede, which would be pretty interesting. The same thing with Titan and its moons. Titan is definitely larger. Wait, no, Titan is larger than Mercury. Yeah, it is. So, yeah, where's Titan? So, yeah, Titan is larger than Mercury. So, yeah, maybe it would do the same with Titan. Titan's got a mass of 1.83 moons, so that is a lot more mass than what Saturn has right now, since it's the least massive in the mass. So, maybe Saturn would orbit Titan. So, that'd be pretty interesting. Uranus, we've already checked out on you, but poor Uranus, man. It's completely lost its hydrogen. It still has all hydrogen on it, but there's just not enough of it to make it into that gas giant phase. So it's a rocky planet with 6% or 6.85% hydrogen on it. So that's pretty interesting. Next up, we've got Neptune, which is relatively the same. It's just because Uranus and Planet 9 as well, they've just got less mass overall. So when you remove a lot of that size, it just doesn't have enough hydrogen anymore to become, or stay as a gas planet. So yeah, Neptune on the other hand probably just scraped in and still has its nice blue coloured atmosphere. I love those clouds. And I believe this is due to, yeah, if you didn't know, Neptune has methane on it. The methane, I think it's methane gas or liquid methane, I don't know. But it's because that methane absorbs infrared light, which makes the colour go blue, I believe. Yeah, I think that's how Neptune has blue clouds. Yeah, correct me on that if I'm wrong, but I believe that's how it has it. Anyways, next up, Planet 9 as well. Yeah, this isn't really going to, well, Planet 9 is not going to be any different. It's just all the way out here. Still going to be dark as ever. It's just a lot smaller. So there's poor Planet 9 out here. Same as Uranus, just too small to hold all that gas in, I guess. So yeah, that's pretty. That kind of sucks for them. Anyways, let's speed this simulation up. Just see if any of the orbits change. Actually, in theory, probably not. None of the orbits will probably change because Jupiter's not got a lot of mass anymore. It won't affect any of the orbits. So the orbits should stay completely they should stay like this permanently. I don't think they're even changed. We can check up on Planet 9 because I know Planet 9's orbit usually does change a lot, but looking at the settings here, no, its orbit looks pretty stable now. Look, you can see its orbital period is just changing between 18,789 and then 90 years there. So yeah, Planet 9's orbit period is pretty calm now. It's not really wobbling around. Sedna is probably the same, yeah, barely changing. Eris is permanently the same, it looks like. And then yeah, so it looks like the solar system is a lot more stable now just because all these objects are smaller. Mercury's orbit's wobbling as it normally would because Mercury hasn't been affected now because we haven't touched Mercury. So anyways, that's pretty interesting. Anyways, Earth, what is the temperature here now? So Earth's at 15 degrees, so overall Earth is just doing normal, but for some reason, or it's just doing normal with a little more surface pressure. But Venus, on the other hand, damn, that's a whole other story. Look at this, it's really hot here. What if we put climate mode on Earth on? Does that make any difference, or is it just... So we put climate mode on now. Is that going to do anything? So anything happening here? Okay, it's still got its atmosphere, so maybe that last time was just a glitch. But is this gonna change anything? We'll speed it up a lot faster here. No, Earth looks good, around 15 degrees as its sort of mid-temperature there. So okay, Earth is fine. Everything else seems, yeah, this is quite a nice little calm simulation here, and nothing too extreme happening. But yeah, there we go, guys. So that is what happens if you make all of the objects or all of the planets, including Pluto and Eris here. Yeah, that's what happens if you make them all the same size as good old Mercury here. So yeah, it's pretty interesting little video that. So hopefully you guys all enjoy. Make sure you did hit that like button, subscribe for more. Any ideas, like I have said, leave them down in the comments. I'll add them to my list of things to do for videos. And yeah, there we go. So make sure you all have a good day, and I'll see you in the next video. Goodbye. As a smaller planet, but with the same atmosphere. So yeah, that could be a little interesting. So anyways, Mercury. Let's go to the main star of the show today. So Mercury, 4.49 masses of moon. It's got a radius of 2,440 kilometers in size. So that's about 4,880 in diameter. The idea, and also if anyone else has got any ideas, feel free to comment them down below and I add them to my list of things to do. And yeah, let's get into this. And also subscribe if you haven't already, because yeah, become one of us. Become one of the math bros, I guess. That I don't know. Yeah, help us on the journey to 1,300 subscribers, because that'd be cool. But anyways, it's gonna be interesting to see how Earth turns out with this. I believe density of 5.43. I don't even know what that is. G/centimeters cubed. I don't. Oh, gram. I think that's grams/centimeters cubed. So yeah, that's pretty high number, but I'm not really very smart with density there. What else? Got age 4.5 galactic years or billion years. Like, I think it was when I can't remember if I did it or not. I definitely made all of the planets 100 masses of sun, and that was insane. But I don't think I can't remember if I've made them all the same size as Jupiter before. I've definitely seen other videos on it. I haven't watched them, but yeah, I think I've seen other videos about making all the planets Jupiter size, but I've never seen anything with making it Mercury size. So yeah, we're gonna get into this because yeah, whoever commented this, many thanks. Hello everyone and welcome back to another Universe Sandbox 2 video, and today we've got quite an interesting idea which sparked my attention when I actually saw it, because if you've seen on my channel before, I think I did it, where we made all the planets Jupiter size, and I think loads of other people have done it as well. But what if we make all of the planets Mercury sized? So yeah, as when we did